Hey, Muso here. So, what's the difference between distance and displacement? These are two terms that we use all the time, interchangeably. We use them in physics left and right. And honestly, we use them incorrectly a lot. We use them incorrectly in real life, and you're going to see me kind of use it incorrectly in physics. It's just common terminology that kind of screws things up. Distance versus displacement. Very similar sounding terms, very similar terms in definition and examples, but there are some crucial differences. First and foremost, a distance is a scalar term. What does that mean? It means it only needs magnitude. We don't care about direction. If I were to define it farther, I'm going to say that distance is better defined as how far an object has moved. Not where it's going to finish, not its final location, but how far an object has moved. Whereas displacement is a vector term. We need both quantity and direction associated with it. So it's not just how far it's moved, but more or less information on its final position is needed. So a good definition for displacement is how far an object's current position is from its starting position. We will often say how out of place, how far out of place the object is, or its change in position. Both terms, the standard unit for the SI unit for physics is the meter. Okay, so little m will be the unit that we'll use when we're talking about either distance or displacement. Now, don't forget your prefixes. There's a lot of common prefixes out there that we can use. You can use kilometer, km, or centimeter, and they all mean different things. You've got milli, pico, nano, you got all sorts of stuff. These are all prefixes, not your standard unit. So make sure when you're given a value in, let's say, kilometers, make sure you go ahead and convert that to meters. And you can look up the prefixes if you aren't familiar how to do the conversion in many different tables or in your textbook. A kilo stands for 1,000. Centi stands for 1/100th. Milli is 1/1000th. All the way down the line. I'm not going to go through every prefix with you right now. Just keep that part in mind. The variable that we'll use to represent both distance and displacement will be more often d. Okay, so these are your variables. We will also use x or y or z, and we typically use these when we're talking about distance along the coordinate system. Sometimes you'll use some geometric terms. You'll have L for length, W for width, H for height. And you might use some of the old school distance terminology like S, often used to represent displacement. And you'll probably see a few more pop up as the year goes on. As long as it represents a distance value, the variable is appropriate. Let's go through and try to give some better examples as to why distance and displacement are not the same thing. Because remember, distance is a scalar term. We don't care about direction. And displacement is a vector term. So let's use an example. Let's say you are walking around a block. Maybe you're not going all the way around the block. Let's say you start right over here. And you go along this portion of the block, 10 meters. So here's position 2. Here's position 1. And then you head up this way, 10 more meters. So here's your final position. Now, like I said, distance doesn't care about direction. So let's say you had a pedometer on your belt as you were walking along this block. A pedometer is a device that will count the number of steps you take. And as you walk around these two sides of this block, it doesn't know that you turned left at this spot. It just knows that you walked 10 meters and 10 more meters, or a total of how many meters? 20 meters. In this example, the distance traveled is 20 meters. Is the displacement also 20 meters? Remember, the definition of displacement is how far out of place the object is, or how far the object's current position is from its starting position. So, another way in which I try to explain displacement is it's really the shortest distance from point A to point B, and it doesn't necessarily need to be that path that is actually taken or even possibly taken. So another way of getting to position 3 that was shorter than going from 1 to 2 to 3 was to just go diagonally across the block. Now, again, this might not have been practical. There are probably houses in the way, right? Or buildings. But if we're talking about actual displacement, the bird's eye view, we are looking at this purple dashed line that I just drew. Our displacement traveled is this distance right here. So how do we figure this out? Well, there's a couple ways of doing it. I'm going to eventually show you how to do this using graphical means. But perhaps you can see that this, in this case, is a right triangle. We can find this displacement vector by using Pythagorean Theorem. Let's go ahead and do that, and we'll figure out our actual displacement. So let's set it up. Remember, Pythagorean Theorem, a squared plus b squared equals c squared. And we are looking for the hypotenuse, which is the c leg. So c, what I'm looking for, it's going to be the square root of a squared plus b squared. And so it's just going to be the square root of 10 squared plus 10 squared, or radical 200. Let me toss that in my calculator, and let's see what we got. I'm getting 14.14. And remember, my standard unit is the meter, and my values for each leg was meters, so that's appropriate. And so this distance, or this displacement, is actually 14.14. That's still not enough information. If I were to tell you that I traveled 14.14 meters if I finished 14.14 meters away from where I started, I don't know if I went, down or left, right, etc. From my diagram, I know where I am, but in terms of responding to a problem, I have no idea where I am. So what I've got to do is state my directional information. So let's say I know my coordinate system. Let's go ahead and assume that this was correct. You got your northeast, your south, and your west up here, right? So that means I traveled in the northeastern direction. For now, it's appropriate to say 14.14 meters northeast. Now, we're going to learn some terminology in which we have to account for the actual angle that we traveled. But for now, we're not going to worry about that. Okay, let me give you another example just to make sure we understand how distance and displacement are totally different. And for that example, we're going to run around a track. I used to coach track, great sport, a lot of fun. And you can do a lap, especially if you're well trained, a lap around that track in about 60 seconds. Some people can do it a lot quicker. I certainly can't. So let's say I'm running around this track. And it takes me about 60 seconds to complete that lap. My question to you is, what is my distance and what is my displacement? Well, in order to know that, you got to first understand that the distance of one lap around a track, or the circumference of a track, so one lap, is 400 meters. Okay? So if I completed one lap in 60 seconds, then that should mean that the total distance I traveled is 400 meters. I think the real question is, what's my displacement? How far away from where did I start am I? Well, think about it. If I completed one lap, didn't I finish right where I started? So isn't the shortest route to where I finished not moving at all? Yes, that's true. My displacement in this example is 0 meters. I didn't go anywhere. Big difference there. And if I do 2 laps, my displacement's still 0. 3 laps, still 0. 4 laps, still 0. But if I complete 4 laps around that track, I'm actually going to have 4 times 400 distance. So my distance is actually 1,600 meters. I hope this is clear. This is where I'm going to end it for now. There will be more examples down the line. Keep this in mind, distance versus displacement. Thank you.